Today we're going to talk about indefinite integrals. So let's start by taking the derivative of the following functions. F of x equals x squared. The derivative f prime of x would be 2x. Let's look at g of x equals x squared plus 7. The derivative would be 2x. What about h of x equals x squared minus pi? Well, its derivative is also 2x. So the function whose derivative is 2x is of the form x squared plus c, where c is some constant. So we say that the antiderivative of 2x is x squared plus c. When you're looking for an antiderivative, you're looking for the function whose derivative is what you're looking at. So the antiderivative of 2x, I'm looking for whose derivative is 2x, and that's going to be something of the form x squared plus 2. Antiderivatives are really important, and so important and special that they have their own notation. So this little S-shaped curve right here is called an integral symbol. So we take the integral of 2x, so this is called the integrand, this is what we're integrating, and then dx, meaning we're taking the integral with respect to the variable x. When you look at something like this, the integral of 2x dx, you're asking yourself, whose derivative is this integrand? Whose function can I take the derivative of to get this 2x right here? And that's going to be x squared, but not just x squared, it's x squared plus any constant, because the derivative of a constant is 0. So when you're finding an indefinite integral, you're looking for all the solutions, keeping in mind that there's likely infinitely many of them, which is why we have to add this plus c, because the derivative of a constant is 0. And so we would read this right here as the integral of 2x dx, or 2x with respect to x, is x squared plus c. So let's look at this example right here, the integral of 3x squared dx. We're asking ourselves, whose derivative is 3x squared? Well, the function whose derivative is 3x squared is x cubed, but we need this plus c. That's called the constant of integration, because it's not just x cubed whose derivative is 3x squared, it's x cubed plus or minus any real number, plus any constant, because the derivative of a constant is 0. You can always check that you found the correct antiderivative by taking its derivative and making sure you get this integrand in here. So if we take the derivative with respect to x of x cubed plus c, the derivative of x cubed is 3x squared, plus the derivative of any constant is 0. 3x squared plus 0 is 3x squared, and we did actually get that integrand right there, so we did that right. Here, the integral of 1 dx. We're asking ourselves, whose derivative is 1? And the function whose derivative is 1 is x plus any constant. So the integral of 1 dx would be x plus c, that constant of integration. And again, you can check, take the derivative with respect to x of x plus c. The derivative of x is 1, the derivative of c is 0, and 1 plus 0 is 1. So we did get that integrand. We do have this nice rule for taking integrals. It's like a power rule almost, similar to the power rule for differentiation, but we don't call it the power rule because we have a different rule called the power rule for integration. So the integral of x to the n dx, we're undoing taking the derivative. And so if you think about when you took the derivative, you brought the exponent down, and that became a coefficient that you were multiplying by, and then you took one away. And we're going to kind of do the opposite of that. Instead of taking one away from the exponent, we're going to add one. And instead of multiplying by that exponent, we're actually going to divide by it. So the integral of x to the n dx will be x to the n plus 1 divided by n plus 1. And then we need this constant of integration because when you're taking an indefinite integral, you're looking for all the solutions. And again, we need that plus c because the derivative of any constant is 0. So there's technically infinitely many solutions. All right, let's look at a few examples here. If I wanted to integrate x cubed dx, I want to know which function, whose derivative is exactly x cubed. Well, using this rule right here, that would be x to the 3 plus 1 divided by 3 plus 1 plus c. 3 plus 1 is 4, so we would get x to the 4th over 4 plus c. You can always check that you integrated correctly by taking its derivative. If you take the derivative of x to the 4th over 4, that over 4 right here is a coefficient. You can just leave it there. The derivative of x to the 4th is 4x cubed. The 4's would cancel, and you'd be left with x cubed plus the derivative of a constant in 0. So you do get that integral, that integrand right there. So you did integrate correctly. Just like with taking derivatives, we don't have a rule for a radical. We just have a rule when it's x being raised to a power. So if we wanted to integrate the cube root of x, we would need to write that in terms of x being raised to a power. The cube root of x is x being raised to the 1/3 power. So now that it looks exactly like this, the integral of x to a power with respect to x, that dx there, we can then use this rule. It'll be x to the 1/3 plus 1 over 1/3 plus 1, and don't forget that plus c, that constant of integration. 1/3 plus 1 is 4/3, so this becomes x to the 4/3 divided by 4/3 plus c. We don't divide by fractions, that's kind of sloppy math notation there. Instead of dividing by 4/3, that's the same thing as multiplying by 3/4. So our final answer would be 3/4 x to the 4/3 plus c. Same thing here. In order to use this rule, you have to have x being raised to a power. Nothing above, nothing below, or anything like that. Well, here, that x to a power is in the denominator. So just like we did with differentiation, we'll bring that up and give it a negative exponent. 1 over x to the 5th is the same thing as x to the negative 5. Now that I have the integral of x being raised to a power dx, then I can use this power rule, and it will become x to the negative 5 plus 1 over negative 5 plus 1 plus c. Negative 5 plus 1 is negative 4. So that's x to the negative 4 over negative 4 plus c. And to write it a little bit nicer, we'll bring this x down to make that exponent positive. And then we'll bring the negative up to the numerator. So it'll be negative 1 over 4x to the 4th plus c. And keep in mind, in each one of these cases, you can take the derivative of our answer, and you should get back the integrand that's inside the integral there. Let's do some more examples. Or actually, let's look at some more rules and then do some more examples. So we have this nice rule that we first talked about. We also have the rule that the integral of 1 dx is x plus c. We already talked about that earlier. We have a coefficient rule which says if you're trying to integrate a coefficient times a function of x, you can take that coefficient, move it outside the integral, take the integral of that function, and then just multiply the c back in at the end. And we also have a sum and difference rule, which says if you want to take the integral of functions of x being added or subtracted, you can take the integral of each of those functions and add and subtract as you go along. So let's look at this one, the integral of 5x to the 7th. That 5 is a coefficient. This rule number 3 right here says I can pull that coefficient out, and then we'll take 5 times the integral of x to the 7th with respect to x. So that'll be 5 times x to the 7 plus 1 over 7 plus 1 plus c. 7 plus 1 is 8, so that turns out to a nice final answer of 5/8 x to the 8th plus c. Now, if you wanted to check this, you could take the derivative. That 5/8 is a coefficient times the derivative of x to the 8th would be 8x to the 7th. 5/8 times 8, the 8s would cancel, and we would be left with 5x to the 7th plus 0, and that does match that integrand right there. Here, if you wanted to take the integral of x squared plus 2x minus 4, all with respect to x, using these rules up here, you can break this into multiple integrals. You can take the integral of x squared with respect to x, plus the integral of 2x with respect to x, minus the integral of 4 with respect to x. And if you do that, this 2 is a coefficient, it can come out front. And this 4 would be a coefficient, 4 times 1, and it could come out front. And so then you can use your power rule, and that second rule right there. So this would be rule number 1, and that would be rule number 2. So then you would have x to the 2 plus 1 over 2 plus 1, or x to the 3rd over 3, plus 2 times x to the 1 plus 1 over 1 plus 1, or 2 times x squared over 2, minus 4 times x plus c. And when we simplify this, we see those 2's are going to cancel, and we're left with x cubed over 3 plus x squared minus 4x plus c. Again, I encourage you to take the derivative of these answers to make sure you get that integral, the integrand right there. All right, let's look at c. We have 5 over x to the 5th. plus 3 over x cubed, and we're integrating that with respect to x. If you look at our rules right here, these don't have anything to do with x being in the denominator. So what we can do is we can bring x up by giving it a negative exponent. So we're integrating 5x to the negative fifth plus 3x to the negative 3, all with respect to x, that dx. Using that first rule there and that coefficient rule, that's going to be 5 times x to the negative 5 plus 1 over negative 5 plus 1 plus 3 times x to the negative 3 plus 1 over negative 3 plus 1 plus c. And when we simplify this and make it a little bit prettier by bringing those negative exponents down, we get negative 5 over 4x to the fourth minus 3 over 2x squared plus c. Let's do another similar thing here with d. The integral of 4 times the square root of x plus the fifth root of x to the fourth plus 4x plus 7. We don't have a rule for radicals, so we'll get rid of those radicals by writing this as the integral of 4x to the 1/2 plus x to the 4/5 plus 4x plus 7, all integrating with respect to x. That's what that dx means. Using that same rule, that's going to be 4 times x to the 1/2 plus 1 divided by 1/2 plus 1 plus x to the 4/5 plus 1 divided by 4/5 plus 1 plus 4 times x to the 1 plus 1 over 1 plus 1 plus 7 times x, and then a plus c. We don't divide by fractions. Instead, we'll multiply by the reciprocal. So that's going to be 4 times 2/3 x to the 3/2 plus 5/9 times x to the 9/5. That 4 and 2 will reduce to 2, so we have plus 2x squared plus 7x plus c. And then we can simplify this a little bit further to get 8/3 x to the 3/2 plus 5/9 x to the 9/2 plus 2x squared plus 7x plus c. All right, let's look at this example here. Same thing here. We don't have a rule when that t is going to be in the denominator, so we'll bring it up and give it a negative exponent. And we don't have a radical rule, so instead of the fourth root of t, we'll write that as t to the 1/4. So we're really going to integrate 6 to the negative 2 minus 18t to the 5th plus t to the 1/4, all with respect to t. Using our rule, that's going to be 6t to the negative 2 plus 1 over negative 2 plus 1 minus 18t to the 5 plus 1 over 5 plus 1 plus t to the 1/4 plus 1 over 1/4 plus 1 plus c. That negative 1 dividing into 6 would give us negative 6. Bring that t down to give it a positive exponent. 18 over 6 gives me this 3. Instead of dividing by 5/4, we multiply by 4/5, and we get a final answer of negative 6 over t minus 3t squared plus 4/5 t to the 5/4 plus c. Let's do an application problem here. All right, suppose the marginal revenue for the sale of x units of a product is given by 2,000 plus 12x minus 0.06x squared. Let's find the total revenue from the sale of 100 units. Remember from previous knowledge that the derivative of your revenue function is your marginal revenue. So when you take the derivative of revenue, you get marginal revenue. So to undo that, if you had marginal revenue must be the antiderivative of revenue. So when you integrate marginal revenue, you'll get your revenue function. So if I want to find revenue and I'm given this marginal revenue, then I'll go ahead and integrate that 2,000 plus 12x minus 0.06x squared with respect to x. That's going to give me 2,000x plus 12 times x squared over 2 minus 0.06 times x to the third over 3 plus c. Now when we go ahead and simplify this, we get 2,000x plus 6x squared minus 0.02x cubed plus c. But I want to know the total revenue for 100 units. Well, what is c? So we're going to have to figure out what c is first. Well, think about what revenue is. Revenue is the amount of money you take in from the sale of your product. If you don't sell any units, then how much revenue do you make? Nothing. So if we sell 0 units, our revenue will be 0. So our revenue function at 0 is 0. So if I plug 0 in for x here, here, and here, that would give me 0. So 2,000 times 0 plus 6 times 0 squared minus 0.02 times 0 cubed will give me, or plus C will give me 0. Well, that goes away, goes away, goes away, so I'm left with C equals 0. So my actual revenue function will be 2000x plus 6x squared minus 0.02x cubed. C is 0, and I don't need to add that plus 0. And so now I can go ahead and plug in 2000 times 100 plus 6 times 100 squared minus 0.02 times 100 cubed, which is going to give me 240,000. So the revenue from the sale of 100 units is going to be $240,000. That's it for this time. I'll see you next time.